Ever wondered why QoS, or quality of service, is critical in switching environments? Let's dive into this intriguing subject. You know, in the world of networking, traffic isn't just vehicles moving on the road. It's a flow of data, a constant stream of zeros and ones flowing from one point to another. And just like with road traffic, it's crucial to manage this flow in a way that keeps things moving smoothly. That's where quality of service, or QoS, comes into play. Imagine a network as a highway. Without any form of traffic management, you'd have data packets of varying importance jostling for space and bandwidth. This could lead to congestion and, in the worst-case scenario, a total gridlock. Not a pretty picture, right? Now consider the same highway, but this time with a traffic cop, QoS. QoS manages the flow of data, ensuring that high-priority tasks are not delayed by less urgent data. It's like allowing an ambulance with its sirens blaring to pass through traffic unimpeded while other vehicles wait. QoS doesn't just prevent congestion though. It also improves overall network performance. By prioritizing certain types of data, QoS can ensure that the most important tasks are completed first. This can be particularly useful in a business setting where time-sensitive tasks such as video conferencing or VoIP calls need to be prioritized over less urgent tasks like email or web browsing. Furthermore, QoS settings can be customized to suit the specific needs of a network. This means that network administrators can fine-tune their QoS settings to ensure optimal performance. So, while it may seem like just another acronym in the complex world of networking, QoS is a vital component of any switching environment. It's the unsung hero that keeps the data flowing, ensuring a smooth and efficient network. So as we've seen, QoS serves as a traffic cop, managing the flow of data and ensuring a smooth and efficient network. Now that we understand the importance of QoS, how do we actually set it up on our switches? Well, configuring quality of service, or QoS, on switches involves several key steps. First and foremost, we need to define traffic classes. Traffic classes are essentially groups of traffic with similar characteristics and requirements. These could be voice data, video data, or any other type of data that your network might handle. Once we have defined our traffic classes, the next step is to configure QoS policies. These policies dictate how the switch should handle each traffic class. For instance, you might have a policy that prioritizes voice data over other types of data to ensure clear and uninterrupted voice calls on your network. But setting up a policy is only half the battle. The real magic happens when we apply these policies to interfaces. An interface, in the context of networking, is a point where two systems or levels meet and interact. In simpler terms, it's the part of the switch that connects to other devices or networks. By applying our QoS policies to specific interfaces, we can control how traffic flows in and out of our network. At this point, it's crucial to remember that QoS is not a set and forget kind of thing. It requires continuous monitoring and tweaking to ensure optimal performance. Luckily, most switches provide tools to help us verify our QoS settings and make necessary adjustments. These are the broad strokes of configuring QoS on switches. Each step involves a number of smaller steps and considerations, which we will cover in the upcoming scenes. For instance, when defining traffic classes, how do we decide which types of data should be grouped together? And when setting up policies, what factors should we consider to ensure fair and efficient use of network resources? With these steps in mind, configuring QoS might seem challenging, but don't worry. We will delve deeper into each step. So, stay tuned for a more detailed exploration of QoS in switching environments, right here on Tech Spectrum Pro. Let's dissect the process of configuring QoS. First up, defining traffic classes. When we talk about quality of service or QoS, we're talking about managing network resources. And a key part of managing these resources is defining traffic classes. So, what are traffic classes? Simply put, they're groups of traffic identified by common characteristics. Now, how do we define these classes? We can define them based on a variety of parameters like protocol type, IP address, and port number. For example, we might have one class for HTTP traffic, another for voice over IP or VoIP, and yet another for FTP. To illustrate, let's say we have a class for HTTP traffic. We could define this class based on the protocol type, in this case TCP, the port number, typically 80 for HTTP, and the IP address, which could be the IP address of the server hosting the website. But why is defining traffic classes so crucial? Well, imagine you're at a busy intersection with no traffic lights. All vehicles, regardless of their size or speed, are trying to cross at the same time. It's chaos, right? Now, imagine the same intersection but with traffic lights allowing different types of vehicles to cross at different times. That's what defining traffic classes does. It helps us manage network traffic more effectively. The key here is accurate classification. It's like sorting mail at a post office. If we don't sort the mail accurately, it won't reach its intended recipient on time, or worse, it might not reach at all. Similarly, if we don't accurately define our traffic classes, we won't be able to manage our network resources effectively. So, remember, when configuring QoS, defining traffic classes is not just a step in the process. It's a fundamental part of the process. It's about understanding your network traffic, knowing what's important, and making sure those important packets get the priority they deserve. Once we've defined our traffic classes effectively, we're one step closer to a well-managed network. Having defined our traffic classes, the next step is setting up our QoS policies. Now, QoS, or quality of service, as many of you may know, is all about prioritizing certain types of traffic over others. It's a way of ensuring that your most critical data gets through, even when your network is under heavy load. Setting up QoS policies is like setting the rules of the road for your network traffic. You're telling your network which traffic to prioritize and how much bandwidth to allocate to each class. Let's delve into this a bit more. Typically, you'll want to prioritize traffic that is sensitive to delay, like voice and video, over less time-sensitive traffic, like email or file transfers. This ensures that your real-time applications perform smoothly, even under heavy network load. To do this, you assign a higher priority to your real-time traffic classes. This is usually done by assigning a higher DSCP, differentiated services code point, value to these classes. But it's not just about priorities. You also need to manage your bandwidth allocation. You don't want your high-priority traffic to completely monopolize your network bandwidth. This is where policing and shaping come in. Policing is about setting a maximum limit on bandwidth usage. If a traffic class exceeds this limit, the excess traffic is either dropped or marked down. Shaping, on the other hand, is a bit more lenient. It buffers excess traffic and releases it when there's available bandwidth. So, setting up QoS policies involves a delicate balance. You need to ensure that your critical traffic gets the priority and bandwidth it needs, without starving your other traffic classes of resources. Remember, the goal of QoS is not to throttle or limit traffic, but to manage it smartly and fairly. It's about ensuring that all your applications perform at their best, regardless of network conditions. With our QoS policies in place, we're ready to apply them to our network interfaces. The final step in our journey is applying the QoS policies to our network interfaces. You've carefully defined your traffic classes and set up your QoS policies. Now it's time to put them into action. Remember, the goal here is to ensure that your network handles traffic according to the priorities you've established. We're going to apply these policies directly to the interfaces on our switch. This might seem a bit daunting, but don't worry, it's a straightforward process. First, access the interface configuration mode, then apply the service policy to the interface. It's as simple as that. Just remember, the direction of the policy is crucial. An inbound policy inspects incoming packets, while an outbound policy inspects outgoing packets. Be sure to apply the correct policy in the right direction. And there you have it, a step-by-step guide to configuring QoS on your switches. But how do we know if our QoS settings are working as they should? Excellent question. It's one thing to configure QoS policies, but another to ensure they're operating as intended. Verification is a critical step, and thankfully, there are several commands and tools to assist us with this task. One such command is the Show Policy Map Interface command, which displays the QoS policies applied to a specific interface. Similarly, the Show MLS Course Interface command reveals the QoS settings for a particular interface. Now, let's take a moment to revisit the key takeaways from this video. We've learned that QoS is not just a luxury in switching environments, it's a necessity. It helps prioritize network traffic, ensuring that critical applications receive the bandwidth they require. We've also walked through the steps to define traffic classes, set up QoS policies, and apply these policies. So, remember, QoS is not just a nice-to-have, but a must-have in any robust and efficient network. Until next time, keep exploring, keep learning.